All right. So this is basically solving some exponential equations. At first, we're going to do some that you do not need to use logs, and then we're going to do some that you do. So please have a calculator out as well. But so this is basically the lesson for the first section of homework 4.03. Okay. So the first part is how do you solve exponential equations by hand, specifically when you have one exponential statement equal to another. What I mean by that is what if I have something like 2 to the 3x equals 8 to the x minus 4? Well, let's do 2x minus 4. Okay, so what if I have 2 to the 3x equals 8 to the 2x minus 4? Well, basically, what happens here is we want to get these to be kind of common. And what I mean by that is I want the same base. Because if I have the same base, then I can cancel it out in a sense. So 2 is pretty easy, but 8, I recognize that 8 can actually be written as an exponential of 2. What I mean by that is 8, just off to the side, I know that 8 actually equals 2 cubed. So in place of this, I can actually say 2 cubed to the power of 2x minus 4. And over here, I'm going to keep it as 2 to the 3x. Well, exponents means that this is actually 2 to the power of 3 times 2x minus 4. And this is 2 to the power of 3x. In which case now I notice, oh, well, the bases are exactly the same, so I can actually just rewrite this as 3x equals 3 times 2x minus 4, and now it just becomes pretty simple algebra. 3x equals 6x minus 4, subtract that over, this is negative 3x equals negative 4, and then x equals 4/3. And so with these problems, for the first 6 problems on the homework, I want answers that are in fraction form, no decimals. Let me do one more example though. So what if I have 49, we'll do 49 to the x minus 1 equals 1/7 to the power of 2x plus 5. Okay, so here's another one, but again, we recognize, 49 and 7. These both can be written as powers of 7. So this is actually 7 squared to the power of x minus 1. And since it's 1/7, this is actually 7 to the power of negative 1 to the power of 2x plus 5. In which case, this is 7 to the 2x minus 1 equals 7 to the negative 1 to x plus 5. Now, solving this fairly straightforward, we can pretty much ignore the fact that this is an exponential. In fact, what's actually happening is, in a sense, what we're doing is we want to get rid of the base. Well, how can we get rid of the base? What operation do we do on both sides to get rid of the base? And really what we're doing is we're taking log base 7 of 7 to the power of 2x minus 2, I just distributed that, equals log base 7 of 7 to the power of negative 2x minus 5. Again, I just distributed the negative 1. Log base 7 of 7 is, the question is, 7 to what power is 7 to the power of this? Well, this basically two different operations, and they are opposite, and so they cancel each other out, and so you get 2x minus 2 equals negative 2x minus 5. You don't really need to write this step, but it's but I like just to show it, right? This is kind of what's happening. You're taking the log of both sides. You do not need to write this step though. This gives us 4x when I add the 2x over. When I add the 2 over, I get negative 3, and so x equals negative 3/4. There you go. So this is kind of how you do the top 6 there on the homework, where you're solving two exponentials that are equal to one another. But what if the next section is just solving an exponential, specifically one that you can't do by hand. So most exponential equations look something like this, where I might have 7 to the power of 3x minus 4 equals maybe, let's do 94. I don't know why I put 94 there. Doesn't really matter. So what about solving this? Well, basically what you want to do is you want to isolate your exponent. Once you isolate your exponent, then you can switch it into a log and solve. So to isolate my exponent, I'm going to add 4 to both sides. So I get 7 to the power of 3x equals 98. Now to solve for an exponent, I need to rewrite this as a log. Now at this point, you might want to get out your calculator and okay. So here's my calculator. Now if you have this calculator, or this type of calculator, you hit the math button and you go down to log base, and that will give me an option to actually type in my base of 7 to the power of 98. That's going to give me 2.356 equals 3x. Obviously, I just want to take that answer and divide it by 3, giving me x equaling 0.785. So this whole section, I just want you to round to maybe 3 decimal places, and that's good enough. So yeah, there you go. I say 3 significant digits, so 3 numbers, right? Anyway, so this is how you can type it in. If you don't have this calculator, what you would also do is you use the change of base formula. And the change of base formula says, all right, log base 7 of 98 is the same as log of 98 divided by log of 7. These are both base 10 now, and so I can just use my log button right here. So I would just hit log of 98 divided by log of 7. And notice I get the exact same thing. Divide that by 3, and I get my same answer, right? There's my same answer. So notice log of 98 divided by log of 7, and then divide that by 3, give me my same answer. So that's how you use your change of base if you don't have a change of base function on your calculator. Let's do another one. I'm actually going to do one, let's actually do one from the paper. This is in fact number 12. So I'm going to do 2e to the power of 3x minus 1 minus 5 equals 73. So first I need to add 5, so I'm going to get 78. Again, I'm still trying to isolate my exponential, which means I need to get rid of my 2. So divide by 2, divide by 2. This is going to be 39. And now I change this into a log. When I write this as a logarithm, this is log base e, but note that log base e of 39 can be written as the natural log of 39. And that's going to equal 3x minus 1. So remember, you can type it as the natural log of 39. I'm then going to have to add 1 to both sides. So natural log of 39 plus 1 equals 3x. Divide both sides by 3. And so that's what x is. So let's do that in our calculator here. So it is the natural log of 39. I'm going to close that parentheses. I'm going to add 1. And then I get this, and I'm going to divide that by 3. So again, 3 significant digits is 1.555. Or no, 1.55. 1.55 equals x. So that's number 12. And that's how you solve exponentials. Let's do one more just to make sure everything's good. So this one's not on there, not on your homework, but I'll just make one up here. Let's do 4 times 5 to the power of 3x minus 6 equals, we'll say 23. Okay, first thing we want to do is we want to get rid of the, let's make this 24 just to make it a little easier on ourselves. Divide both sides by 4. that gets rid of that. We get 5 to the 3x minus 6 equals 6. This is going to be rewriting this as a log. This is log base 5 of 6 equals 3x minus 6. Log base 5 of 6, again, we either hit this, which is 5 of 6. There you go. Or you can do log of 6 divided by log of 5, right? So I can either use my base or my thing where I can change the base of the log, or I can write it like this using my change of base formula. Whoops, didn't mean to put the plus there. And notice we get the exact same answer. So this is 1.113. Now let's just do the rest of the problem on the calculator. We note to move the 6 over, I'm going to add 6, takes my final answer, and just add 6. So this is equal to 3x minus 6, or 7.113 is equal to 3x, or x is equal to 2.37. 3 significant digits, and we are done. So that's how you solve exponentials. So that pretty much does the first side, the first page of your homework 4.3. So good luck with that, and be sure to write down any questions you might have, and I'll post another video in a second. All right.